this thing going. Alright guys, how's it going? This is Mr. Brewer here. This is tutorials for circles. Just trying to find a pen that works. This is 7-6, the circles. If I can figure out how to work these pens. There we go, got it. Okay, circles and arcs, 7-6. Circles and arcs. Focus that there. There it goes. Okay, so number one, this is looking at the homework packet. The first one, trash. The graph shows types of trash in a typical American city. Find the measure of each central angle to the nearest whole number. So it gives us a pie chart, and it gives us a percentage of each of the categories. So paperboard is, for example, is 38%. And it wants you to find the central angle. So remember that a circle has 360 degrees in it. So using that info, we can figure out how much each portion. So the first one is glass, which takes up 6% of that. Okay, so remember the way to do this is first you find your you put down your degrees. There's 360 degrees in a circle, and we're going to multiply this by 6%. In a calculator, 6% is 0.06. So just get very good at moving that decimal over two places. That's the same as dividing this by 100. Remember, a percentage is a decimal times 100, right? It gives it out of 100, whereas a decimal is out of 1. So we can either divide by 100 or just take that decimal point and move it to the left too. So when you put that in a calculator, let me pull up a calculator here on my computer. 360 times 0.06 is 21.6 degrees. So the central angle of glass is going to be 21.6. I'm going to skip the even one. I'll do plastics. Plastics was 10%. So we want to do 360 times 0.10. So multiplying something by 0.1 is the same as taking that number that you started with and dividing it by 10. So I'm going to take that decimal here and move it to the left one place. That'll be 36 degrees. So plastics take up 36 degrees. So if you put 36 into a calculator and you divide it by 360, that's the total number of degrees in a circle, you'll get 0.1. If I were to take this number and multiply it by 100, which is how to convert from decimal to percentage, you get 10%. In other words, we are going one way here, this way we're going the other way. So this tells us that plastics make up 1/10, that's 0.1. They make up 1/10 of the total of the pie chart. Number 5 is food waste. Food waste was 11%. This one not so easy, so let's put this one in a calculator. We're going to do 360 times 0.11. 360 times 0.11, that's 39.6 degrees. And then other is 10% again. We already computed 10% up here with plastics, so other will be 36 degrees. Alright, go ahead and flip the page. Number 9. Identify the following in the circle. So you have a circle here. It's drawn on your page. But basically you have, looks like 5 points, F, E, D, C, oops, I should be right about there, C, and then B. And number 9 says it wants you to identify a minor arc. A minor arc. So remember, minor arcs are less than a semicircle. So any of these arcs, right, so an arc, remember, is just a portion of that circle. So any of these arcs that is less than a semicircle, like see right here, FE is less than that semicircle. So FE would be a minor arc. Another one would be ED or DC or FB or CB. Anything that's less than a semicircle. So major arc is number 10. So review the notes if you are confused about major arc. That's going to be greater than a semicircle. Number 11, it wants us to identify exactly a semicircle. There's 2 here. BE and CF are both semicircles. Okay, those are both semicircles, and you can call these also, so you want to call it CEF, or you want to call this one BCF. That's totally okay, just so long as that middle letter includes a point on the circle that is between the two that actually create that semicircle. So CEF is still the arc that makes the semicircle. Number 13, an acute central angle. So we want to find an acute central angle. Acute, remember, is less than 90 degrees. And the central angle is going to be from the origin. Each side of the central angle will head out to the points on the circle. So, for example, this space right here, from this line to this line, would be a central angle. This would be acute since it's less than a 90-degree angle. So we could say that the angle FOE, remembering that the O is the center point, that's where the vertex is, that would be an acute central angle. Another one would be EOD, or DOC, or COB. This one up here would not be acute, since that is clearly larger than 90 degrees. 90 degrees is going to be a right angle. Just take your fingers and go like that. You've now made a right angle, okay? That's a right angle. Okay, moving on. Number 15. I want to find the measure of each arc in the circle P. Okay, so there's plenty here to do. Circle P, P in the center. It's got C out here, D, B, and T. That's a right angle. The angle up here is 128 degrees. We want to find the measure of arc TC. So the arc TC is going to be from T all the way to C. The central angle there is 128 degrees. The measure of that arc is the same as the central angle. So the measure of arc TC is 128 degrees. Next one, 17. BTC. Let's look at that here. B to T to C. B to T is a right angle, so that's going to be 90. So that's going to be 90. And then we're adding TC, which is 128. So it'd be 90 plus 128. So that's what, 218 degrees. Next one, 19, we have measure of CD. Alright, so check it out. So TD is a semicircle. The semicircle has 180 degrees. CD is the portion that is not T to C, which is 128. So I'll do 128 minus, 180 minus 128, which will be 52 degrees. Next one, 21, TCD. TCD, this includes all the points that's in the semicircle up here. There's 180 degrees in a semicircle, so that's 180. TDC, so this is going the opposite way. TDC, so TD is a semicircle, and then we're adding DC on top of that, which is, we said, was 52 degrees, so that'll be 180 plus 52. That's going to be 232 degrees. Next one, 25. The measure of BC. BC goes from B down here, stretches across all the way up to C. This angle, one last time, is going to be 52. This angle here is going to be 90. Why? Because TB is 90 and TD is 180, so 180 minus that 90 is going to be 90. So the measure of angle BC is going to be 90 plus 52, which will make it 142 degrees. Now that is assuming, that's a big assumption here, that we are going from B to C this way. It could be we're going from B to C this way. So if the answer is different in the back of your book, that's because they went to the left. I'm just going to go out on a limb though and say it's going to the right, 142 degrees. I'm not sure why. I just chalk it up to not enough information given to determine if they want us to go to the left or to the right, since they only give those two points. However, if they had said BDC, I would know for sure that we're going to the right, since D is in between B and C. If they had said BTC, then we're going to go to the left, since T is in between B and C. Alright, let's go to number 27 on your new paper. 27. Find the circumference of each circle. Leave your answer in terms of pi. So number 27, we have a circle here with a diameter of 20 centimeters. Remember, the circumference is going to be pi times diameter, or it's going to be pi times 2 radii. So radius would be the center out to the outside. So it gives us the diameter. Leave it in terms of pi. So this one's real simple. It's just we're going to plug in the diameter there and then times by pi. So the answer is 20 pi. Let's go, let's do number 29. So our circle here, this time we're given a radius, 4.2 meters. This time, since we have radius, I have to use the bottom equation, pi times 2r, or 2 pi r. So this will be pi times 2 times 4.2. So that'll be 8.4 pi meters. I forgot the units up here. This was centimeters. This will be meters. Number 33. I'm going to skip 31. I'll do number 33. The wheel of an adult's bicycle has diameter 26 inches. So the wheel has a diameter of 26 inches. The wheel of a child's bicycle has a diameter of 18 inches. This is 18. To To the nearest inch, how much farther does the larger bicycle wheel travel in one revolution than the smaller one? Remember what I said before, if you took this circumference here and you laid this out like a flat line, you took this circumference and you laid it out like a flat line, you can see that the larger wheel, this is really just approximation, the larger wheel would travel farther in one revolution, so it would go from here all the way out to here. The smaller wheel would start here, it would hit here. So to find this, we have to find out what the circumference of each wheel is. The larger wheel is going to have a circumference 26 times pi. The smaller wheel will have circumference 18 times pi. And I'm going to use my calculator to approximate this. So in your calculators, if you have them at home, you want to use, I've got to zero this out here. Okay. So if you have a button that says pi, go ahead and use that. If not, I would advise against. 26 pi is, just trying to figure out how to work this thing. Times pi is going to be 81.68. 0.68 inches, and then 18 times pi is going to be 56.55 inches, and we want to figure out the nearest inch. So this line is 81.68 inches, and the smaller one is going to be 56.55. So to find how much farther this line goes than this one, I need to find the difference. And difference is going to be a subtraction problem. So I'm going to plug in 81.68 minus 56.55, and I get this distance here we're trying to find. This is 25.1. It wants it to the nearest inch, or nearest tenth of an inch. So our answer is 25.1. What does that mean? That means that the adult bicycle wheel is traveling nearly 2 feet farther than the kid's bicycle wheel per revolution. So bigger wheels, you get farther per revolution. However, that doesn't mean that bigger wheels automatically equal farther distance per less energy expended. It takes more energy to make that larger wheel go one revolution. Because it's a larger wheel, there's going to be more friction on it. Yeah, so that's a nice, interesting physics problem. Alright, number 35. Find the length of each arc shown in red. If you're looking at your page, there's no red ink. However, I did go in here and I drew arrows. This signifies the arc that is red. Okay, so it wants us to find the length of each arc in red. Okay, this portion out here is 60 degrees, and I want to find out how long this arc is. Okay, so first I need to find out what the angle of this arc is. So how many degrees is this arc? Well, from here to here, this is a semicircle. It's half the circle, so that's 180. So this guy is going to be 180 minus that 60. So it's 120 degrees. That's how many degrees are in this part of the arc. The next thing I need to do is multiply this by the... So I need to figure out how much of the circle is 120 degrees. There's 360 degrees total in the circle. This little section is 120 degrees. So if I simplify this, I can see that this little section is 1/3 of the circle. So from here to here, I'm looking at 1/3 of the entire circle. This little section is 1/3 of the entire circle. To find out the length of this, I just need to do the circumference times a third, or the circumference divided by 3. So let's get that circumference. Circumference is 24 pi, and it wants us to leave it in terms of pi. So I have pi. I don't need to do anything with that. I do need to multiply this number by a third, since I'm finding a third of the entire circumference. So this is going to be 8 pi. That's how long this section of the arc is. This is 8 pi. Okay, so if you're a little confused about this equation, how I got this circumference, again, this is circumference equals pi d. Since I'm given diameter, it's 24 feet across, I can use this equation. Let's look at number... I'm going to go on a limb here. I'm going to do number... I'll do 36 and then I'll do 39. So let's look at 36. This is an occasion where I would use the formula for circumference using radius. And if you're looking at your page, this would be number 34. We're going to use that same formula. So I want to find the length of this arc. Okay, so this little chunk here is 90 degrees. That means this chunk is 360 minus 90. So this is 270 degrees. If you think about that, that's 270 over 360. That's 3/4 of the circle. So I need to find out what the circumference of the circle is, how far it is all the way around it, and then multiply that by 3/4, since I'm just looking at 3/4, or 75% of the circle. So I'm going to use the equation 2 pi r. Why? Because I'm given radius. So you need to use the equation that contains radius in it. So circumference here would be 2 times 18, so that's 36 pi. Notice here, once I multiply radius by 2, that's actually the diameter. Since the radius is half the diameter, that's why you have two different equations. If you're given half the diameter, you know you need to multiply by 2. So in this case I did that. I multiplied my radius by 2, and then I got the diameter. This is actually going to be pi d. This is pi times the diameter. Okay, so this is the circumference of my circle. I'm looking at 75% of it, so I can multiply this by 0.75, or 3/4. And then I should get, what would that be, 27 pi meters. So this arc here has a length of 27 pi meters. And then last bit we'll do number 39. Ooh, this one's good. It's got some fun stuff here. So we're given the radius there, and I'm given the fact that this out here is 25 degrees. I want to find the length of this section. Okay, I've got 2 lines here. These are straight lines. Remember alternate or vertical angles? These are definitely vertical angles, since it's created by 2 straight lines. So I've got vertical angles. That means that this section is 25 degrees. So I need to figure out how much of the circle that is. That's 25 divided by 360. Let's punch that in a calculator. That is a weird number. I don't like it. Let's reduce this by 5s. So this is 5. I'm taking out a 5 here. I'm seeing if it ends in a 0, so it's divisible by a 5. This would be 7, 1, 2. This is 72. This is 5 over 72. Okay, if you put that in a calculator, you would see that it's 0.0 0.692222, something like that. So this is 5/72 of the circle, this little portion, and I'm going to multiply it by the circumference. The circumference here is 2 pi r, so 2 pi r, since the radius is given, so that's going to be 18 pi. So I'm multiplying 5/72 by 18 pi. Maybe this will work out for us. I'm going to do 18 times 5. 18 and 5, that's 90. So I get 90 pi over 72. And then I think I can reduce this. Yeah, I can take out 9s. So I'm going to reduce this by 9s. So this would be, if I factor out a 9 out of each of these, I get 10 over 8 pi, which is 5/4 pi. Did it give us a unit? It did. 5/4 pi meters. So that is how long this little section of the circle is, with a lot of fancy fraction work. You could have also factored out 18 out of these numbers, but that wasn't so obvious. Okay, so this is 5 pi over 4 meters. Alright guys, thanks for tuning in. See you next time. Bye.